In this video, we are going to talk about how to write Newton's polynomials using given number of points. Before we write Newton's polynomial, let's look at an example. Let's say we have 2 points. One point is 2, 3 and another point is 4, 7. These 2 points could also be looked as. Now using these 2 points, we want to write an equation. We know that if 2 points are given, we can write an equation of a straight line. Equation of straight line is y minus y naught equal to m, which is slope, x minus x naught, and x naught, y naught are the coordinates of a point through which the line is passing. So we can take 2, 3 as x naught, y naught, and using the points 2, 3, 4, 7, we can find the slope of the straight line. So the slope would be 7 minus 3 divided by 4 minus 2. For the slope, we have used this formula that if 2 points are x0, y0 and x1, y1, then the slope would be y1 minus y0 over x1 minus x0. So the slope here is 4 by 2, which is 2. So we have the slope and we have a point. Then we can write an equation of the straight line which is passing through these 2 points 2, 3, 4, 7. So the straight line is y minus y0 is 3, slope is 2, x minus x0 is 2. We simplify this and it becomes 2x minus 4 plus 3, which is 2x minus 1. So using these 2 points 2, 3, 4, 7, we have written an equation of a straight line, and we can see that the degree of this equation is 1, means the maximum power on x is 1. So instead of writing it y, we can write it as p1 of x, polynomial of degree 1, 2x minus 1. Remember, this polynomial has been written using the 2 points 2, 3 and 4, 7. So this polynomial p1 of x equal to 2x minus 1 must satisfy these 2 points. What is the meaning of this? That if in the place of x you plug this 2, you must get this 3. Let's see if we are getting 3 by plugging 2 in this polynomial. So when we do that, we get 4 minus 1, which is 3. So this polynomial satisfies the point 2, 3. Let's check if the polynomial p1 of x equal to 2x minus 1 also satisfies another point. So in the place of x, in the polynomial p1x, we will put 4 and we must get this 7. Let's check that. 2, in the place of x we have 4 minus 1, 4 to the 8, 8 minus 1 is 7. So the second point is also satisfied. What we are seeing here is that if there are 2 points given, x0, y0, x1, y1, and using these 2 points you write a polynomial of degree 1, then this polynomial must satisfy these 2 points. That is, in the place of x, when you plug x0, you must get y0, and when you plug in the place of x in this polynomial x1, you must get y1. Another thing that you have seen here is that if 2 points are given, when you write a polynomial using these 2 points, the maximum degree of the polynomial will be 1. The same way, if we are given, let's say, 3 points x0, y0, x1, y1, x2, y2, and using these 3 points, if we write a polynomial, the maximum degree of the polynomial would be 2. So we would write this 2 in the base to represent the degree. The same way, if we have, let's say, 4 points x0, y0, x1, y1, x2, y2, x3, y3. We also say that these are 4 data points. So for 4 data points, when you write the polynomial, the maximum degree of the polynomial will be 3, p3 of x. How shall we write this polynomial? We will try to understand now. So let's begin with 2 data points. Let's say we have 2 data points x0, y0, x1, y1. Using these 2 data points, we will write the polynomial. We know that if 2 data points are given, the maximum degree of the polynomial is 1. So we will write 1 degree Newton's polynomial. So Newton's polynomial is written as p1 of x equal to a0 plus a1 x minus x0. a0 and a1 here are Newton's polynomial coefficients as well as unknown. So we will have to find these unknowns. We have used these 2 points to write a 1 degree polynomial, which is p1 of x. So this polynomial must satisfy these 2 points. How so? That in the place of x, when you plug x0, you must get y0. This is called one condition. Another condition is about the second point, which is x1, y1. That is, if in the polynomial of degree 1, you plug x1 in the place of x, you must get y1. So this is a complete polynomial that from the 2 given points, you can write a 1 degree polynomial, 1 degree Newton's polynomial. In this 1 degree Newton's polynomial, there are 2 unknowns or 2 Newton's polynomial coefficients, and since there are 2 points, so there are 2 conditions that polynomial will satisfy these 2 points. p1 of x0 is equal to y0 and p1 of x1 is equal to y1. We will use these 2 conditions to find these 2 unknowns. So let's call this polynomial of degree 1 as 1 so that we could refer to it. Now we are using these 2 conditions, p1 of x0 equal to y0 and p1 of x1 equal to y1, to find these 2 unknowns a0, a1. So for first step, please compare p1 of x0 equal to y0 with p1 of x equal to a0 plus a1 into x minus x0. That is, we are comparing this equation p1 of x0 equal to y0 with p1 of x, the polynomial of degree 1, a0 plus a1 x minus x0, which we have called equation 1. Now let's look at the left hand side only. p1 is same as p1, x0 is same as x, so we will say put x equal to x0 in this equation or in equation 1. When we do that, p1, in the place of x we have x0, everything else remains same, a0 plus a1, in the place of x we have x0, x0 is already there, using this condition is equal to y0. So we will only copy y0 from the left hand side, and the right hand side is a0 plus a1 into 0, which gives us a0 is equal to y0. So we have found one unknown, which is a0, and its value is y naught. Now let's use the second condition to find the other unknown, which is a1 in equation 1. So the second condition is p1 of x1 equal to y1, and we are going to compare it with the polynomial p1 of x equal to a naught a1 x minus x naught. Let's compare the left hand sides first. p1 is same as p1 and x is same as x1. So we will say put x equal to x1 in this polynomial or in equation 1. This is our equation 1. When we do that, we get p1 of, in the place of x we have x1 equal to a naught plus a1. In the place of x we have x1 minus x naught. From this condition we know that p1 of x1 is equal to y1. We will copy only the left hand side, which is y1, and the right hand side is a naught plus a1 x1 minus x naught. Now we know the value of a naught already, which is y naught. So we will plug that value, a1 x1 minus x naught. From here we will extract the value of a1, which is another unknown. So we have y1 minus y naught divided by x1 minus x naught is equal to a1. So we have found the second unknown, which is a1. So what we had was 2 points x0, y0, x1, y1. We know that if there are 2 points given, the maximum degree of the polynomial will be 1. So using these 2 points, we wrote Newton's polynomial of degree 1, which was a0 plus a1 into x minus x0. And here we had 2 unknowns or Newton's polynomial coefficients a0, a1. We found the value of a0 as y0 using the condition p1 x0 must be equal to y0. And we found another polynomial coefficient a1, which was y1 minus y0 over x1 minus x0 using the condition p1 x1 equal to y1. So this Newton's polynomial now becomes p1 of x equal to a0, which now we have found is y0, a1, which now we have found y1 minus y0 over x1 minus x0 into x minus x0. So we got Newton's polynomial of degree 1. Now the problem is, if we have, let's say, 3 points, using the 3 points we can write Newton's polynomial. So we know that if 3 points are given, the maximum degree of the Newton's polynomial will be 2. So we can write p2 of x. And how do we write Newton's polynomial? So see, the degree is 2 here. So we will write Newton's coefficients, Newton's polynomial's coefficients, which are a0 plus a1. 1 means that here we will write 1 degree factor. Since the degree here is 2, so we will stop at a2, and 2 means there are 2 1 degree factors. Now what is the 1 degree factor along with a1? It would be x minus and the x coordinate of the first point, which is x0. Along with a2 we have to write 2 1 degree factors. 1 degree factor will be the same as was used in the previous step, which was x minus x0, and the next one would be x minus this coordinate x1. Now here we have three Newton's polynomial coefficient, and we can find these coefficients by using three conditions. These three conditions satisfy these 3 points, meaning that if in this polynomial p2 of x we plug x naught, we must get y naught. If we use this condition in this polynomial, we will get a naught, just like how we got a naught in p1 of x. If we use the second condition, p2 of x1 equal to y1, we will get a1. And if we use the third condition, p2 of x2 equal to y2, we get the third coefficient a2. You can do some calculations and you will see that using these three conditions, you get a naught as y naught, which was the same for p1 of x. You get a1 as y1 minus y naught over x1 minus x naught, which was also same for p1 of x, and you will see that a2 will be 1 over x2 minus x naught y2 minus y1 over x2 minus x1 minus y1 minus y naught over x1 minus x naught. So the 2-degree polynomial, 2-degree Newton's polynomial could be written as, in this polynomial p2 of x, we will plug the values of a naught, a1, a2. A naught is y naught, a1 is y1 minus y naught over x1 minus x naught into x minus x naught plus a2, which is 1 over x2 minus x naught, this expression inside y2 minus y1 over x2 minus x1, y1 minus y naught over x1 minus x naught into x minus x naught into x minus x1. So this is the Newton's 2-degree polynomial using the given 3 points x0, y0, x1, y1, x2, y2. You can see that if we are increasing the points, the polynomial coefficients, which are a0, a1, a2, they are getting complex. So we have to find a way to write these Newton's polynomials using different operators so that we can express these polynomial equations in simple form. For this, we will try to understand forward difference operator, backward difference operator, and divided difference operator, and we will convert these Newton's polynomials in those operators forms, which you will see in the next videos.